Jim's been very much associated with different approaches and perspectives on the nature of how the universe works, and we're very interested to learn more, Jim. Thanks.
Thanks very much. If we can get a slide up, we can do it. Yes, the bottom one, right. Thank you. Okay. Rather a provocative question, right? What then is light? When Lawrence asked me to do this, my initial reaction was no. So you know. But eventually, as friends call it, a little bird says, no, you must go do this. Okay, so here we are. It's a question that I'm going to talk about at the beginning, if I can make all this work, with some quotes. Sure most of you know something like that, Alice Bailey. The substance of things hoped for, the evidence of things not seen. So we're going to talk a lot about that, because this is a meditation of us, and actually a story of the meditation of the human race on light, on space, on consciousness. And you'll see that as we go through this. As we do it, as you go through this, see if I can keep working that. There we go. I want to remind everybody, I have to remind myself, that science is a human experience, as we know. Sometimes I get the feeling people feel, well, science is something we discover and this is truth. But it's really something that we're doing as humanity to understand the world. And I like her quote. It's very deeply personal to the people in the field, whether you're a scientist, an engineer, whether one's deeply in it, or whether you're on the periphery. It's often flawed, because we're humans, right? And it's frequently groundbreaking, however, i.e. leading to some new understanding of the world. Dr. Stephen Phillips, I like this quote when he wrote his book a few years ago, reminds us we do not see the world the way it is. We see the world the way we are. We see through our consciousness and understanding. Now, Dr. Phillips is a physicist. He's a string theory physicist, one of the major people involved in the field, who some 15, 20 years ago, somebody gave him a copy of Occult chemistry, which, of course, in that world of physics is not something you talk about, occult and chemistry in the same word, phrase. But he was astounded to find out that when he read the book from at that time, about 80 years before, Ledbetter and Besant, that their descriptions and drawings of the first 16 atoms were essentially the same as quantum mechanics and string theory had discovered by the 1970s and 80s. And of course, he asked the question, how did somebody know at that time, some 60 years, even 100 years before, what those atoms looked like, since no instruments existed to do so? I end this first slide with this one from John Muir, who was a naturalist in the United States. When we try to pick out anything by itself, we find it's hooked to everything else. So we're going to go through several quick slides on light. And you'll find, of course, it's hooked to everything else. If we go back to that first quote up there. So, what is light? If you go into history, one of the first people who wrote about it, and we have knowledge of, is a Greek, Empedocles. Most people think of Aristotle and Plato, Socrates, etc., etc. But actually, if you go look into it, you find the first one we know of is Empedocles, and all these rest talked about Empedocles and referred to Empedocles, a Greek from what is today Sicily. I like the drawing. There he is, explaining to the world, this is what it's about. He said there were 4 elements, you know that from history: earth, water, air, fire. We call that solid, liquid, gas, and plasma. Interestingly enough, they are virtually the same way he described it back then. But he used the Greek terms, not our terms. He also said they went into union and were parted and pulled together into things and then split apart again. He called the things that caused this love and strife. It's very easy to read the ancient things and think about, what are you talking about love? What are you talking about the elements fighting? Until you go look at the language and study it and their descriptions of these words. And you realize, oh, love is my attraction to someone, or two things attracted to each other. And strife is an ancient word meaning I'm repulsed by it, or I'm pushed away, or we're so alike we really can't get along. And if you think of it as attraction and repulsion, then much of this changes. That it pervades the universe, it waxes and wanes, each one is stronger and then weakens in a cyclic manner. That it explains the harmony of the universe and the variation, and you can see it in human behavior. Now this is 2,500 years ago. It's just pretty insightful, it seems to me. He also said light exists in its particles. A tremendous insight in that time frame. And that your vision is absorbing these particles, and that's why you see. And he pushed the concept that souls go into matter. We call that reincarnation of all life. And talked about what now we call the evolution of matter due to the cyclic nature of the energy of soul through matter. So there it is, the Ageless Wisdom. We can go home now, right? It's all there. Now, I know and sure that people talked about this before 500 BC. No doubt the Egyptians, no doubt many, many others. But we simply don't have the records. But we do have this one. So let's go through some quick slides that give this. So here's a list of people that we know from history. You can see Empedocles. He's not the only one. There are people in the Indian subcontinent. There's some you can find in Chinese. There's a little bit you can find in the Americas, from what records we have. Unfortunately, most was destroyed in the Spanish times there. And of course, there's some in the ancient Egyptian, but much of that has eventually gone. But if you summarize that 500-year period, what did we find? That atoms, atomic or particle, and it's the same as energy. That things travel in straight lines if it's light. And if there's interactions from your eye and the sun, they argued whether the eye sent something out and interacted with the sun or not. There were the first theories of light, reflection or refraction through lenses, and the first concepts of space and what that might be. What's most interesting to me is that they also talked about that everything is a state of consciousness. And you can read that through all these writings. You can just even go Wikipedia, which I find a fascinating place to find data. I'm not always a big fan of it because, of course, it has its biases. But even they talked about this funny phrase, conscious. And we'll come back to that at the end. That kind of stayed that way for 2,000 years. It's a long time and became sort of dogma. Until these people came in the 16th, 17th century. Two things did that, as far as I can tell in history. One was a funny victory called, in 1588, the Spanish Armada. And there's no doubt from history they got beat badly by the British. The storms up north, but down towards Scotland, didn't help the Spanish cause. But what most people don't know is that the cannons weren't built right. If you fire a cannon and shoot your bow, of course it goes out and curves, right? Force of gravity. But that's not what Aristotle said. Aristotle says it goes out until it loses energy and drops. And if you're Spanish and you're part of the Christian religion at that time, you're going to dang well follow Aristotle. So the cannon is designed to go out and go boom. But there had been a Henry VIII who said, I don't like all the money going to the church, I want it kept here, whatever you think about him. And new ideas were allowed, and they came along and said, you know, when it goes like that, it's always curving, so if you want to hit over there, you aim like that and let it drop. So the Brits did that with those little ships, and the Spanish went whoosh, and the Brits went whoosh, and that didn't work out too good for the guys going this way. So that knowledge was preserved through the Islamic worlds, actually, but lost in the European worlds. And when it came in, speaking of a point of tension, it just changed things. Light, they said, is a wave, a particle, and a wave, and somehow is polarized. This glasses that you have to keep the sun out. All its meaning is that light moves along in a wave, and the electrical is going this way, and the magnetic is going perpendicular to it, whatever that meant. But found out hundreds of years ago, with new theories of reflection and refraction. And so they established the idea that light is a particle and a wave at the same time, whatever that means. But the discoveries kept coming. Sometimes I look at it as a change, the very beginning change from Piscean to Aquarian age, if you think about that esoterically, what was happening in the world then. And light is this transverse wave I'm mentioning, shown by experiment, not theory anymore. It fascinates me that 2,500 years ago, people figured that out, and they'd had no experimental basis to show it. But indeed, it turns out to be true. Those particles were polarized. They actually measured the speed of light hundreds of years ago, fairly accurately. And they did something called a double slit experiment. What does that mean? It means if I send a light or an electron through a single slit, I get the pattern in that upper right. Those in the back may not see the lower one so well. If I send it, so there's two slits, it interferes with itself, which proves, of course, it's a particle, but it's a wave. It can go through both sides. And that was not done 50 years ago. That's done a couple hundred years ago. And so the wave theory became, that's light. It's a wave. They also said you can't escape in a high gravity. You get enough gravity, it'll stop it. That's actually, we think of black holes starting in 60 years ago, the theory. You have to actually go back about 250 years. The later thought just says why. So experiments is advancing understanding. One of the things that attracted me to what people call esotericism or occultism, now for me about 45 years ago, was cosmic fire. And it was because of the point that you have to be, as we say, an occultist, but you also have to be a mystic from your heart, from your head, the mind. And the experiments is what I think is bringing that together. Well, the last century, this continued. You recognize many names: Maxwell, Hertz, Planck, Röntgen, Tesla was famous to many people, Dr. Einstein, etc. And, not that I went the wrong way, there we go. It established what we call it today, electromagnetism. It's an experiment, it's both. Radio waves are the same. Like waves gain and lose energy in some kind of quanta. And they explain this through what's called the photoelectric effect. If light hits the surface, a particle comes off of it, as people know. It comes off as a single, quote, quanta of energy, and it proved that old theory that it was quanta. But also that there's plasma, and that's that fourth one. Because up until then, back in the Greeks, here, what do we have? Earth, we got water, we got air. Where'd that other one come from? 2,500 years later, people go, that's matter that's also electrified somehow. Matter and electricity go together. So it's hypothesized. And there it is. There's the sun. That's a big ball of plasma. It's matter, highly electrically charged at all times. You'll see in the reports of NASA or the European equivalent that that's gas. What you may not know is it's called gas because they don't think any of you will understand what it means if I say it's got electricity in it, so I'll just call it gas. It's not gas. It's not gas at all. A gas is not electrified. My observation is, however, when you use the wrong words, you follow the wrong thought. And so you begin to think of things as a gas instead of thinking them as something else. You know this every day. That's a plasma screen at the sports complex. Now they're going to solid state. There's a light bulb that's just almost going out now as we try to make them look even different. There's what's called the child's toy, where you can have a ball and electrify it and play with it and excite your neighbors and friends and so forth. Try to break it and find out you shouldn't do that. And that's the basis of light in all of modern physics. So what's modern physics? Well, this electromagnetic radiation, which is some particle that's accelerated, and it's charged, and it's a wave and particle. It's massless. Wow, that's really interesting. Where'd it go? And it's massless but affected by gravity. What does that mean? You barely see this Earth there and this warped thing. The concept is that a planet, a star, has mass, and space and time are warped around it, and the light must follow that warping path, so it appears to be affected by gravity. But it's massless. It's polarized, as I mentioned. It has these particles now shown by experiment. So Empedocles got it right. And it's the foundation of our world, right? X-ray, radio, radar, etc. So what is it in everyday use? Well, there's everyday use right there. On the top is an old AM radio. Anybody have an old AM radio? I still got one. Amateur radio, aircraft communication, remote control, light bulbs, that UV, those wonderful airport security scanners we all love going through, positron, electron, scanner, and there's even gamma rays that come off lightning, whatever that means. You can see the difference is frequency, but it's all the same. It's just frequency. You can look at it this way. There's the frequency. On the far left, radio's got a wave as big as a building, a mountain. That's how long that is. And gamma rays are the size of an atom, so we can use it to penetrate and understand those. And there's our visible light, as a narrow little thing. On the top is this yes, blank, no, blank, yes, no. That means those things go through the atmosphere or not, depending on it. And that's why mankind can't see very much beyond this planet, except in that sort of optical region until we develop new instruments and put them in space. Which is why actually we remain ignorant in many ways until we could do those. Lasers, everybody got them all over the place now, right? All light. That's our modern world right there. Right? That's the basis of it. Sure you've all heard of quantum mechanics. There will be no test after this. It's good because I couldn't pass it either probably. But quantum mechanics says light is particle and wave. That's what Empedocles kind of talked about. But it also says it's neither a particle or a wave. And it says, but we never lose the two qualities. And you can't imagine it anyway. So is that clear? Okay, good. How does this relate to esotericism, right? What do we do now? Okay, so what's light in esotericism? Positive energizes, negative is the receiving. Light is this harmonic, the waves, got that. It's a radiant energy, and somehow it's related to the equilibrizing of positive and negative. Everybody asks me, is that a real word? No, but it's an awfully good word. But it's not quite equilibrating. It's not quite something else. It's related. That light is matter in motion. And it flashes forth, right, from the pairs of opposites, right? I'll read that. Interplay of poles. It's synonymous with substance. It's the thing in the nucleus of every cell. Cell in the general term, right? Not the cell in the... And it's related to law of attraction and repulsion. Okay. We're right back to this love and strife stuff. Well, what is that? Well, physics says law of attraction and repulsion is electromagnetism. Esotericism says it's love. And it coordinates matter and spirit. And it holds everything together. We know it gathers what we call divine life out of all the kingdoms and the deity out of us when we work a little more on this detachment, right? And the controller of our systems, even to the logos, as above, so below, produces this cyclic effect. Somebody said that a few centuries ago. Oh, and it says sound is the agent. I'm speaking, you're listening. This was about light, right? Well, it's the agent, attraction, and repulsion. I'm just going back to one of the authorities. What does that mean? Well, if you think of sound as a relation, I'm speaking, you're hearing. You'd like to think of it as a vibration off of my mouth, moving the air to your ear. But it's also giving information, as every speaker has today, of a relationship between their thoughts and the listener's thoughts, and vice versa, which I find very, very interesting. On the higher planes, speaking of sound, I love this thing behind my ears, is an entity that wields the gravitational law, cosmic law, to the solar system. On the lower planes, he describes it as the astral light, fixing and perpetuating past, present time. I mean, we often talk about time. Is it real? Well, it sure seems to be. I get older. And yet, if you think about it as a relationship between the past and the present, then it's real, but it's an illusion. And in lower vehicle, it's electricity, prana, the magnetic fluid. In other words, light. That's an interesting way to think of light. In the worlds, the planet, stars, are the effect of sound, life, matter, attraction of matter to life, for purpose and arranging matter into necessary forms, the relation between. Okay, I thought this was something that had to do with gravity, so what's that? I assure you, there's no test at the end, okay? What is gravity? Well, we'll reverse it. Physics, it's attraction between matter, caused by gravitons. We have never found any, but they must exist, because otherwise you wouldn't have it. It moves at the speed of light, or it doesn't. It's instantaneous, because both experiments show both are true. Depends on how you do the experiment. Esotericism says it's an aspect of the law of attraction and repulsion. But the standard model in the world, whoever made these things did not do the best job for my ears, is gravity is the dominant force in the universe. That's how we think of it in physics today, not electricity. So let's look at that. Here's the Big Bang hypothesis. It really has good reasons. I'm sure you've all heard of it. Some point in the past, whatever that means, remember what time is, what past and present is, was a beginning. And the galaxies form out of it, and over time, they get further and further apart. And there's some good reasons for that in the last 100 years. Dr. Hubble proposed that the further away something is, the light seems to shift in frequency towards what we call the red. In the 60s, accidentally, not really accidentally, people in radio discovered what seemed to be a background radiation throughout every direction you look, showing there's something from the primordial world. And they did a great job, and people received huge prizes for these, like Nobels. Excuse me, I'll go back one. Nuclear synthesis, it works. I mean, we do build bombs, good, bad, or indifferent, and they work. And the cosmic structures, the big galaxies, has to all relate to this. But Hubble repudiated his theory a year before he died and said he was wrong. Now, you might think if somebody said, this is my theory and I got all these awards and I said I'm wrong, we might listen to him. But the answer is no, you're wrong. You weren't wrong, we are right. It's an interesting world that maybe redshift is something else. The cosmic background radiation means that no matter where I look, I see it all the same. Up, down, back. But it turns out it isn't. It's asymmetrical. It looks different in different directions. So it questions that. Maybe it's not cosmic. Maybe it's local. Lithium, there's one of these elements. Without going into chemistry, I'm just going to say one of the things you can measure as stars is the content of certain elements, and lithium is an easy one to do that with. So I can calculate how much lithium should be in a star after so many millions of years. Done. Do the calculation, and then look, that's an old star because its redshift is long. Okay, what's the lithium concentration? It's less than 10% of the prediction. The atomic bomb would not work if we were off 90%. Would not be a good day. So there's a question. And galaxies, structure. But when we look deeper into space, because that's further away, because the redshift proved it, they're larger, not smaller. That's a bit of a problem if they're older. And the older ones should have a lower surface brightness, farther ones, because they're new at that time, right? But the surface brightness of the near ones is the same as the old ones. This is a problem. This isn't me talking. This is the physicists looking at it. They're saying, this is really quite a point of tension, isn't it? We have a meditation to do here. So Dr. David Bohm, one of my favorite physicists, wonderful guy, involved in a lot of this theory, long time ago, March, said there's no Big Bang, no universe beginning or end, there's no expansion and contraction, and it's all wrong. And the physics world is listening to that one. And so are the Japanese and Chinese and others who are doing some fascinating work in this area. I'm not saying Dr. Bohm's right, and don't please go away and say Jim Ryder proved that there's no Big Bang. I didn't say that. I'm simply saying there's an interesting discussion happening in the world. Oh, you've heard of dark matter and dark energy. Let's play with that one. Standard model. Again, good technical reasons. Why? Well, galaxies, I used to be able to say rotate like a record. Nobody has records anymore, right? I do, but I'm weird. What does that mean? Well, it means if I have a CD, a record, and you can see it on the upper right, think of your solar system. Mercury goes around the sun in 88 days. Pluto wanders around in 100 years or so, you know. The further out they are, this takes longer to go around. So all the time, Mercury's lapping us, and Venus is lapping Mercury, and Saturn is waiting for us all to slow down because he's taking a long time. And that's A. That's the way it looks. A galaxy should be along A, just like the solar system, because it's gravity. But instead, it rotates like B. The stars all the way out on the edge go around just as fast as everybody in the middle and at the inside. That's a problem. And so dark matter is the theory that was proposed to fix that. There's matter we haven't found. Has to be true, right? Well, remember those redshifts? Okay. Hubble was right, but the redshifts aren't doing that, so something else is causing that. It's not matter, so it's called dark energy. That's where it comes from. I'm simplifying a lot of people's hard work, but that's what it comes down to. So the universe is 68% dark energy, 27% dark matter, and 5% matter. That's a lot to miss. This spring in Nature is the first publication of showing the dark matter tendrils and fibers in what's called the Dark Matter Survey and the Dark Energy Survey. We have no laboratory evidence of it, and the direct evidence is really debated. That's why the studies. Now, this is not my words. There's a lovely person, Dr. Sarah Bridle, professor of astrophysics, University of Manchester, some country called UK, right? She is the investigator of the Dark Energy Survey. So there's 4 people involved. Dark Energy Survey has 2 leads. Dark Matter Survey has 2 leads. She's the and the spokesman for them. She wrote, based on this data, her quotes, not mine, the data might show this mysterious force, dark energy, dark matter. On the other hand, the theory is inadequate for explaining it, even if it does. And might even show that relativity theory is wrong. Just quoting her. If anybody wants the papers, I send them all to them. This one I like. The simplest theory we have to explain dark energy is terrible, but it's the best one we got. We expect something weird to happen, and then she quoted her at the end, we don't understand what we see. This is a community of meditation trying to understand what is happening in this universe. And to their credit, my compliments to them all, is that they continue to really face it. Now, a little more recently, this month, May, came the first results of a new study looking at what's this funny matter we're seeing between our galaxy, Milky Way, and Andromeda. Remember that picture on light? Yes, no's, yes, no, yes, no's. We now have instruments to look through those no's because they're out there in space. I know a little about them because my company built a lot of them, and I had the luck to oversee a lot of those, and thank God they work. This is a view of Andromeda, that little tiny point up in there. That galaxy near to us, 2 million light years away. And then there's the sea of something around it. And now it's realized, this was just published in Nature, that around it is matter. It's very, very low density. But it's also a big place. And the total matter surrounding the galaxy is 10 times the matter in the galaxy. Remember those numbers? 90%? How big is this? The nearest star is 4.3 light years from here. It takes 4 years for light to go there, 300 and some odd thousand miles per second. How big is that volume? Do you have any idea? Let me give you a picture. Take every star in the whole galaxy, 400 billion, and put them all like billiard balls in a bag. They'll fit inside between us and the nearest star and have mostly empty left over. That's how far 4 light years. In fact, you can fit the whole dang galaxy here and 5 more and not run out of space in that 4.3 light year radius. But it isn't empty. There's all this other matter that's sitting there. We didn't know until now. So, new discoveries and a new tension. So, let's take a look at that new tension. We've discovered the cosmic web. Here's another one. What does that mean? Well, remember, new data. Haven't we all experienced this in our life? I know what I'm talking about. I understand this stuff. I've read Alice's books. I've read Carl Jung's psychology. I've read piles of others. What do you mean I didn't get it? That's why I liked the talks earlier. Every time you go look at it again, you go, okay, let me think this out again, right? What's this? Well, this picture, see if I can get the laser pointer, right there. And this picture, this is an artist's drawing. This is a false color. All those pretty pictures you see of the stars, you've seen them all, right? Anybody own a telescope? You ever actually looked at a picture through the telescope? It's absolutely boring. There are no colors. None. All those pictures are painted in by artists. Okay? So you'll buy the pictures and put them in your office and say, look, they're gorgeous things. But that's not what they look like. But it wouldn't sell to put up there a black picture with smoke. right? So the colors are in there to give you a hint of what they would be if you could see them. And you can't because of the density. So this one here is that. And this one is an artist of it, and this is another way of looking at it. Now, how big is this? That little line is 400 million light years. Sort of a big number. Between us and Andromeda is 2 million. So distance between us and the next galaxy, well, shoot, grain on the film wouldn't even be that, would be further away. This is all galaxies. Trillions of them. In nodes, this is the way it kind of looks in reality. This is the way it looked in an artist. This is another one. Oh, and it's in 3 dimensions. If I assume it's far away, it's 3-dimensional. And if I go think about that, all these galaxies and filaments and walls and voids form a web-like 3-dimensional structure of immense size. This is not even counting the 90% of the matter that's around each galaxy that's interacting. This is just the other 10%. Those intersections are empty. The cellular structure, it's empty. That was the conclusion less than 2 years ago. But we can say the universe is an organized structure. Pretty amazing. Okay, the voids, wait a minute, are not empty. Chile, down in Chile, at the desert there, has built the world's largest radio telescope. It's tens of miles on a side with hundreds of dishes put together on laser connection rods. And you have to time all those things because the stuff coming from that and from that are miles away, and even at the speed of light, that's not fast enough to coordinate. So you have delays in them so all the data comes in right to form an image. And they want to calibrate it. How would you calibrate your new instrument to make sure it's seen truly black when it's black? Well, you point it at a black, right? You don't point it at a red. So we'll point it at a void. And so they pointed it at the void. That's in the void. It looks just like the others. It turns out it's full of galaxies too, every one of those. It's just that they were frequencies we never thought about. This is what mankind is finding. Everything. Voids might be smaller than we ever thought. Space is not what we thought it was. Well, so there's a cellular structure even inside the galaxies. Here's our sun. This is our local group. There's some things around here. There's Leo. Up here's Pisces, Centaurus, et cetera, et cetera. These are all the constellations we know from the 12, right? And we're sitting in the center, and the stars are forming groups in cells. They're not just randomly distributed. This platter is not a platter of even stars. It's got density and thickness to it, and it's in groups all the way. Light, the local group, is cellular, just like the galaxies themselves are cellular. It's even down to us. So here's the sun. Here's a star called Antares. Here's the second star in Canis Major. There's Betelgeuse, Betelgeuse, as everybody likes to say in English, over in Orion. And it's a bubble of energy. Thought to be created by supernovas, but there aren't any around there. But that's the best guess. All bubbles are connected to all the other bubbles in a 3-dimensional pattern, all the way down to us. So let's look at that. I know about IBEX, Interstellar Boundary Explorer, very well because it was built in my lab. And it discovered a ribbon in the sky. This is what we think we were going to see. Here's the sun. It's moving through the galaxy, and it has energy coming off, and it's thought of as an aircraft. There's some bow wave, the shot beyond, where the gas is in. Remember that word, gas versus plasma? And we expected to see the flow of the galaxy right here. But we didn't. We missed it. Remember Voyager 1, Voyager 2? They were sent out to find the edge of the galaxy. Never found it. The solar system. Why did they miss it? Well, it turns out the most interesting thing One of them went inside, and one of them went outside of this ribbon. So they find out that the heliosphere is not a tail, it's some cloverleaf of energy that's opening. Very different than expected. That's the head of the program at Southwest Research Institute in Texas for NASA. A totally unique, unexpected structure. A whole new paradigm has come about. Here's the solar system, except now we're a little tiny dot in the center. This is all the interaction. The lines are the flow of matter around us, and this artist's conception is this ring. And it changes. And at 6-month time frame, it's moving around. That's very fast for something that's a third of a light year. And the medium ahead of it we're moving towards is rotating, turning in space. And it turns out there's magnetic fields between all these stars. That's that interconnection I showed you. And they drape across the heliosphere, and they squeeze it and pinch it and turn it and rotate it. And that external field is affecting it, and it's much bigger and totally different. And as the scientists said, we do science because we don't know, thank heavens. We built it on what we believe we know, and that's how we build the instruments. But because of that, we miss what's there. So we build another instrument to prove we're right, and we make it more sensitive and find out, oops, that's the way science. Remember I said it can be profound in what's changing? It's a human experience. Magnetic fields everywhere. We're looking down at the M51 galaxy. It's like ours, but we're seeing it heads on, and you can see the variations in electrical fields. Those are the colors. This is our galaxy. We're on the edge of it, so we look along a slice. And the darker regions are very strong electromagnetic radiation. The lighter is less. Little striations, there's a direction. This is a crosscut of radiation around our own sun, our own planet. The materials are moving in the radiation field. They're not just sitting there, and they're intertwining like taffy. And there's positive and negative. All this has been discovered in the last 4 or 5 years. It's very recent. And of course, you already know it goes down to the cellular level, down into the atom, this cellular structure. Magnetism is everywhere. Historically, we didn't think of electricity in space because there's too few atoms, and the positive and negatives are so far away it doesn't matter. But if there's magnetism, there's electricity. And we know cellular structures at all levels, and this somehow is becoming very important. Well, let's go back to gravity. Gravity. We don't know the mechanism. That's disturbing in physics. We don't know the mechanism. But we did predict there'll be gravity waves. We would pick them up as a wave of matter. There are 2 major instruments. These things cost a couple of billion each, just so you know. They have just reported their works, GEO 600 and BICEP 2. GEO 600 is German, BICEP 2 is a European-American, South American combination. Major, major groups. There's fascinating articles on almost the trauma of scientists who built whole lives of careers on these things and sold them that we build it, and I think it's good they did sell them. Both have reported nothing. They thought they found it, and they have realized they are looking at light bouncing off of dust. It isn't a gravity wave. That's a tremendously fascinating result. And Dr. Stephen Hawking, one of the major inventors of the concept of black holes, that's black hole, remember that? Light can't get out. In Nature of last year, February, he wrote the lead article. It's a whole 8 pages long. And he said, I was wrong. There are no black holes. Light does get out. The theory is incorrect. Hasn't bothered anybody since, by the way. You can still read about black holes, right? Black holes in the center of every galaxy. I'm a huge admirer of that man. He has, if you know about him, he has only communication with one eye, and he has an interpreter that does that. He can do what Vince and I know, second-order tensor equations, the worst dang math you ever want to do, in his head, and he's right. And then he communicates it to somebody by winking his eye. Shoot, I'd have troubles writing them down, nevertheless winking my eyes. but he says is wrong. Plasma, where is that? There's that funny word. Seems to be every place where we are. Is it 99.99%? Remember what I wrote one of the charts from 100 years ago? We think that might be true. And less dark matter and dark energy the other, and you see the questions. Plasma is interesting. It explains that the galaxies should rotate exactly the way we find it. And that the universe ought to be cellular and filamentary. So maybe it is ubiquitous. It's a question. I'm going to spend one chart on some new thoughts that people are looking at. But this is the leader. Dr. Feynman recently passed away, one of the great physicists, mathematicians of cosmology, wrote this in his last book, in his chapter on gravity. There is no model of the theory of gravitation today. Stop there. Other than math. That's an incredible statement. No physics concept of why it would even exist. If you think of three atoms, and there's a few more in the table here, and the Earth, and if you think of them as a bar magnet, they might line up just like that. And in fact, if you do the math and assume that, then a planet is a little electrical negative on the outside and positive on the inside, like a bar magnet, except spherical. And it turns out, if you calculate that total force, it equals the gravity force. And you can't shield it. I don't know the theory is right, but it's at least somebody's proposed a theory. And there's quite an excellent book out on it. It was published last fall, and a gentleman who published it died about 2 weeks later. So I guess we can't have an argument with him. But he's left his theory. If it's right, it means gravity is a form of electromagnetics. And that gravity can be repulsive. But it just takes a lot of it. But a black hole is a lot of it. And in fact, if you go through this math, it says it ought to throw things out. And in fact, is that what a black hole is? And that's why you see the rays? A question. And light, if that's right, is some kind of a wave in what we call neutrinos. Now, neutrinos are these particles that are called neutral. And I don't have all day, and you probably don't want to do it to explain what a neutrino is. But how many are in the room right now? I don't think you got a lot of atoms? You do. There's 60 trillion neutrinos for every square centimeter passing through your body right now. 60 trillion. That's a lot of stuff. In fact, if you think this every square centimeter, don't think about how far away each one is from the other. If you just divide it by the centimeter, then there's 60 trillion. It's like they're everything. And that's just coming from our sun. We're not counting the other stars. If this is right, then gravity and electromagnetics are the same thing. And gravity is the non-locality, that everything is connected to everything else, and there's this interaction over time that's light. Are they one physical concept of attraction and repulsion? Is mankind on the verge of finding that? It's a question. Well, let's look at quantum mechanics. Remember quantum mechanics? Back there, we went through that. Mass and length might not even be fundamental. Well, that's kind of silly. I can put my scale out. This isn't coming from me. This is coming from Quantum Magazine, August 2014, not even a year ago, in their section on theoretical physics. Quantum Magazine publishes sort of like newspaper articles, but they don't do it of the news. They do it of science in a specific area, which is quantum mechanics. And they do an interesting thing. If I had given a talk there on the latest stuff in quantum mechanics, then journalists would write the article and send it to me, did I get it even close? Which is fair, because, it's easy to misquote. But they're asking that question. They're asking the question about the atom, made of protons and neutrons. They're made of quarks, the subparticles, which is in fact what Ryder and Occult talked about 100 years ago now. And you sum the mass up, and the mass of the atom is 100 times greater than the sum of the parts. It's not a good day in theory. Across the pond from us, across the little short one is from you guys right now, is CERN. Tremendous place, and they're doing a lot of fascinating physics. This is the summary from last summer while CERN was down to increase its energy to look more at this question, because they weren't finding it. This is quoted by the lead author there. The collisions have failed to yield any of our particles included in all of our equations for 30 years. Nothing we predicted has been found. Maybe we took a long turn. I think it's extraordinarily brave and a compliment to say something like that. Symmetry, remember my quote from, we look at the world not as it is, but as the way we are. It was done to solve the problems. It predicted dozens of new particles and to account for dark matter. But we didn't find any of them, and we're not even sure we found dark matter. And there's this lovely science quote. You have to understand science a bit to say, Higgs is not protected. You know, sort of like saying Thomas isn't protected. What's that mean? Well, in a sense, he is, because there's people around him, you know, and your sphere of space is protected by this awareness. There must be a person, because it kind of looks like the other person. Higgs is the same thing. We found this particle, but it's at the wrong frequency. Remember that frequency? It's a much higher frequency. And it's at the wrong amplitude by an order of magnitude. And there should be side particles, but there aren't any. Now you know why CERN is putting the energy level up. This is their quote from it, as to there's a real issue here. The only hypothesis is that we have a multi-universe. It disappears from one universe to the next, and there's lots of math on that, and it slips out into the other. And as the lead author said, it's pretty unsatisfactory when the only theory that explains it is a theory that can never be proven. That's his quote. Actually, I disagree. I don't think math is wrong. You can do math wrong, but I don't think math's wrong at all. But we can apply the wrong math to the problem. And that's what the world is wrestling with today. Okay, so then what then is space? It's a simple question. What did the Greeks say? Let's go back to the beginning now, about to the end here. It's the cosmos, it's ideas and forms, it's the one. Esoterically, that's not bad, although I'm still not sure what the one is. Remember those other pictures, 16th century? We talked about the ether, spiritus. That's what they claimed. Fresnel, in the 19th century, said, well, the ether, if it exists, there must be some drag as things move through it. Michelson-Morley fame 100 years ago, showing there was no ether, and it's now the accepted theory. But that experimental interpretation is really being looked at right now, of the questions around it, because it made assumptions. It says, there's no ether, I'm going to prove it doesn't exist. That's not maybe the way you wanted to go about it. So I'll do it by setting it up this way and this way, relative to the Earth. But it made an assumption as to how we move through the universe. Different way of thinking about it leads to different answers. So is it right? Is it wrong? Some people call ether the deep dimension. Well, there's non-locality, photons, particles, in space. What does that mean? Some of you may have read, if I have two particles, say two electrons, I send one that way, one this way. My friend Lawrence has a magnet, he flips this one over. Thomas over here registers what's happened. He says, look at that, it turned over at the same time. How about I move Thomas and Lawrence 100 kilometers away and we'll do it again? Same time. Speed of light is what? Actually, it doesn't matter if it's 1,000 kilometers or anything else. Okay, that's a hard one. Time. Time is real, except they're related in time, as if there was no time. Okay. Quantum state. Quantum is solid. Space and time. I think this is one of the most interesting experiments ever performed in 013, 2 years ago, a year and a half ago, recently published. I send a single particle of light out, whatever that means, but we can do that experiment. My friend Mintz here absorbs it with his instrument. It's gone. Okay, it's gone. Waits half an hour, turns his instrument on and sends another particle out, keep going. How come his particle looks exactly like my particle? That's pretty tricky. In fact, that experiment's been done. So his particle knows mine came in, but it doesn't exist. So they're not only instantly related in space, instantly in time, they even know the memory of the other that doesn't exist. That's a real quandary to get at what that means. Space and time. It's as if everything exists simultaneously in some way. All times, what is that? Information always exists. Not necessarily all the pieces, but the information. Some say it's like a hologram, where you can take a picture and you keep blowing it up, you keep seeing the other, but we do it in a 3D. There are now new terms. There's no ether, remember that statement? But there might be a cosmic plenum. Or there might be a new ether. That one I really like. There might be a matrix. We made a movie about that. Fancier terms are fractional quantum Hall state. If you would like to stay over, we could talk this evening for a couple hours what that might mean. There's string nets. There's an amplituhedral theory. My physics friends ask, what is an amplituhedral? It means that time and geometry of space are 4 dimensions and they're intertwined, and that's what all things are. The key point is, empty might not be empty, is what we're asking. Maybe it exists. What do you mean the vacuum's not empty? Ancient metaphysical concept, right? Everything's interconnected. Pervasive energy, see. Physics today, quantum vacuum energy exists everywhere. Vacuum fluctuations, central role. What does that mean? Just let you read that. Everything's in touch. Everything's underlying structure. The vacuum is subject to influence by consciousness and intention. If you have 2 parallel plates, take my hands, and I ask Christine to push them together, they'll come together, right? Unless I resist real hard. If I have 2 parallel plates and I evacuate the vacuum, so I have a vacuum, okay? And I push them together, what will happen? Will they touch? Yeah, the good bet is Jim's tricking, so it ain't going to touch. And you're right, it will never touch. That's because it's not empty. It's full of something. There's even people trying to develop starships based on the energy out of that. I don't think they will, because I don't think they understand what they're talking about in that point. But there is something, and it's not empty, and it's well proven experimentally. And then there's those last 3 there. Same ideas coming from different fields is getting us here. So, as my friend Dr. Puthoff said, it's like the manifest universe is instantly, intrinsically interconnected. And that space-time is some kind of an entangled cosmic matrix, whatever that means yet. All beings are in an interpenetrating, interdependent field at all times, interconnected at all levels. This isn't coming out of any esoteric reading. This is coming out of science starting to face what's in the world. As he wrote, the boundary lines dissolve between the physical and metaphysical. Dr. Putoff is a physicist in the United States, has been involved in this a long time, and this was recently published in a major book this last fall. It's like there's an ever-changing energetic information and cosmological unity. Does that mean consciousness is ubiquitous? That's what Empedocles said 2.5 millennium ago. Well, okay. Shall I go on? Well, the philosophers say there's some conception of nature. Now, these are recent people about consciousness. These are people, world alone, talking in the last 12 months in their publications. Thomas Hegel is one of the world's renowned philosophers, but he's a philosopher, what does he know? Materialism, materialistic conception of nature is almost wrong, must be wrong. When he wrote that, his friends, you can go look us up on the web, went, what was he smoking? Dr. David Chalmers is another one. Some kind of consciousness pervades the stuff of the universe. You didn't write that 20 years ago and keep your philosophy position, but people are saying it today. Biologists, Dr. Stuart Hoffman, another big name in the field. Darwinian theory must explain the emergence of complex, intelligent creatures, and if it doesn't, he goes on to say we have no idea, because clearly we haven't done that. Physicists, I still can't make real sense of quantum theory as it stands. Dr. Lee Smolin is one of the leading quantum physicists in the world, and a burr under the saddle of many of us, because he keeps saying stuff like that. But he is a really good technical person, and everybody knows it. Light is the potential of everything, is what Dr. Baum recently wrote in his new book. Consciousness is something they're beginning to investigate, and we've already talked a little bit about telepathy. Does telepathy work? Yes. I have no doubt about it. Can you communicate with another person telepathically? Yes. Can it be proven experimentally? Yes. It's been done many, many times, thousands of times, and it works just fine. I can tell you for a fact, governments have looked into telepathy to use it for the purposes of invading other people in a secret way. But why don't we use it? We don't use it because we can't make sense of it. If I get an image of something I've never seen before, I have no clue what you're looking at. So you give it up, not because it doesn't work, because you can't use it for those reasons. But it does prove it works. Physicists and physicians. You can all read, they're talking about near-death experiences, but not just from stuff 40 years ago, but doing the hard technical work. Life after death, I'll put it up there and come back in a minute. They're talking about something called reincarnation, the evolution of consciousness, and in quantum mechanics, the Italians are taking the lead on this in their physics work, that the structure of the brain looks like consciousness is independent of the brain, and the brain is the receiver, and there's something primary called soul. You risked your career 30 years ago, not anymore. It is a different world. So science is studying this big time. What then is light? Maybe we've found our way a bit. I first entitled this, What Then Is Light? Have we lost our way? But I decided that, as a friend said, have we found our way? Well, we know all is electricity, electromagnetism. Everything is cellular and conscious is what it's beginning to say, and everything's connected in space-time. That's what it's starting to say. I know esoterically, light is synonymous with matter, essence of consciousness, medium of inspirational ideas, and I put all the dots because we'd be here all day talking about all the other things. But the connection is rather fascinating that's happening in the science world. I wrote John Muir, and we've done this. We've tried to pick out light, and we talked about everything else. But it does come back to that term, light. Now, this time, not saying what we thought light was, but what it might actually be. And it's what science is starting to look at. Lawrence put in, I don't know it at the time, challenged me, this space is an entity thing. I told my wife, this is the hardest talk I've ever had to put together because I had to go really hard. So thank you, appreciate it. AAB. But having seen all this, well, this is about one last chart after this. Let's talk about it. Well, if it is true, I'm just pulling out of AAB stuff, it reads to what? In him we live and move and have our being, right? Well, if everything is conscious, I guess that's true. The planetary centers and planes are states of consciousness. I think we just said that. We are studying ourselves in relation to this all-enveloping entity. Well, we are, and the scientific world is working on that. I always was intrigued in cosmic fire that it's occultism that will prove soul and consciousness in life. Not because, as you saw from Empedocles, that the mystic can't, but the experiments have been coming for 2.5 millennium, and they're going down this path, as far as I can tell. It is the realization of the directions from where the energies come from, which empower life and motivate action. The sources of all life and origin of life and all. I mean, that's right out of that. I think we just spent about 40 minutes saying that. So yeah, maybe space is an entity, secret doctrine, and it's the same as Paul wrote 2,000 years ago, wherever Paul was, the cosmic Christ, the body of Christ in which we live. Okay, stop.